Hello, welcome you to my YouTube channel Data Engineering Concepts. My name is Nilesh and today we are going to learn what is MCP server. Okay, so it's a very buzz term in today's AI world. You may have heard it everywhere, you know, at least once MCP server thing through the Reels, Instagram, or anywhere. So today we'll just go through a deep understanding what is MCP server, what problem it solves, and why it got this name Model Context Protocol. So MCP basically stands for model, C for context, and P for protocol. Okay, so let's get started. All right, so let's think of scenario. Let's go into the year 2022. I think this was the time when chat gpt 4 was launched, either in October or November, and later on we have many more models came like Claude, GPT, Gemini, Grok, and there are a lot of other meta models as well. So like, think, what if people ask, okay, can you connect my Claude to my BigQuery, or can you connect my Airflow to the Claude, or GPT, can you connect Slack to the Claude GPT and read the messages and all, or Postgres database. So what people do started doing at that time was like, they started writing some scripts, you know script. So LangChain, we had a LangChain for this purpose. So they developed one method, to connect to the models with their subsystems like BigQuery, Airflow, Slack, or Postgres. So they started writing one script for, if we have four subsystems to connect. In this case, like, consider this scenario only, we have four subsystems. So for Cloud, if you have a Cloud, you need to connect one to the BigQuery, one script to the Airflow, one another for the Slack, and therefore for the Postgres. And let's consider that you work at an enterprise level, and you have different models for performing different purposes. Maybe Cloud is for the writing the codes. GPT you are using somewhat like documentation and all. Gemini maybe you're using for images, or maybe documentation, both. So maybe depending on the use cases, but still you want your GPT to access your BigQuery. So again you have to write one more script to connect, another script for Airflow, another for Slack, for Postgres. Probably you'll be using APIs and all, but see what the problem is. So every time a model needs to connect, you are writing another script. Similarly for Gemini, you are writing. So essentially what we are doing, we have three subsystems, and for each model you are writing one script. So essentially we have 3 times 4, it means 12 scripts. So this is basically n times m integration problem we have here. So people started realizing that this is becoming a problem, especially specifically if you want to switch from one model to another, or you are using multiple models at the same time for different use cases. So even the managing things sort of started becoming a kind of integration started becoming a challenge. So people, or basically the Cloud teams, started thinking of different finding out the solution for these cases, and they came with a very good approach. And let's see how we can solve it. Let's say, what if we can have something which can sit between the systems and between the models. So what if something is there, and model just needs to connect with them. Consider this as a system X, and this system X can connect with this. Okay, so now if you are going to add any other model, any new model here, let's say we are having Grok now, or DeepSeek. So all you just need to connect the X, and X has already connected with all those subsystems. So ultimately you are connecting with this. So here, so this is what main thing. And now here X, so X was basically your, sorry, right. So X was basically your all right, let me just clean this a bit. So X is basically the our MCP server, model context protocol, and it's a it's something that sits between, you know, the systems and the models, and defines a way to connect together, and it solves that n times m integration problem. So essentially you just have one subsystem or one MCP server, and one MCP server, you know, you just need to connect that MCP server for that particular system, and you just need to, you know, connect that MCP server, and that can ultimately get. So every time you don't need to you know, write a different script for different subsystems, for different models, I'm sorry. Okay, let's move to the next cycle here. So now we have learned what MCP actually solves. Let's try to learn uh, why its name, what its name stands for. Okay, so MCP basically stands for model, context, and protocol. Okay, so why it's called a protocol, not a tool or library, right? So let's try to understand, like, you know, the word protocol is not new to the technology. We have been you know, using this protocol for the decades. So think about the HTTPs. What HTTP stands for? Hyper Text Transfer Protocol, right? Hypertext Transfer Protocol. So when you type any URL like www.facebook.com, so okay, so when you type any URL into your browser and press enter, your browser sends a request to you know, web server, and web server uh, so how does that web server know what format to use? How does the server know how to respond? So they both follow what, the different set of rules, a set of standards, and same way the browser does not care which operating system the server is running, and the server does not care from. So sorry for this glitch. So let's say we have a web server. Here you are sitting your browser. So here whenever you send a request, web server does not care whether you are using OS or Android or anything else. Same way browser does not care on which OS or systems it is running on. So why? Because they are following a kind of agreed rules and agreed standards, and they both know what language this web server speaks, and uh, what language the browser speak, and which is the that same thing we call it as an HTTP, basically the hypertext transfer protocol. Because uh, so same way, what Claude has done, so they have defined a set of protocols, through which, you know, MCP servers can be exposed by different organizations, so that they can connect with different models by following that, you know, protocols or rules, and that's why this term protocols came. So this is a set of you know, standard rules and agreed rules, so that solve this n times m integration problems, and every time a model, you know, needs to connect, they just have to follow this MCP server protocol, and they just need to connect with them, and you are good to, you know, all your subsystems can connect directly. All right, hopefully, you know. So why we are not calling it library? Because we are not installing anything. Why we are not calling it framework? Because not we are essentially, we are not building anything, right? We just you know, it's something we are, you know, something that sits between your two systems, like one is model and another is your subsystems, and you have some rules, so that there is no kind of a vendor lock-in thing. So any model plus any tool that follows the rules can connect together. So this is a standard rule. We have HTTP, SQLs, there are JDBCs, Java people know more about that, and now we have an MCP. So MCP is basically model context protocol. Okay, let's move to the. So here the same thing which I have explained to you. So let's say we have All right, sorry for this. So let's say we have MCP protocol, it's connecting with BigQuery, connecting with Airflow, connecting with dbt, Postgres, and here we have GPT-4, Claude, and Gemini. So here we have just one MCP server connecting in between. You write write once and connect everywhere. So you just need to write in one MCP protocol for each systems, and later on all the models whenever you will add new one, they just have to need to connect with this MCP server, and this MCP server is already connected with the subsystems you wanted to connect, and so eventually we just have one time 1-into-1 connection, right? Okay, now that we have understood what is protocol, we know it's a set of agreed rules so that we don't get this vendor lock-in thing. Now let's try to understand what does context actually means. So context is something, whenever you start chatting with a model or any AI, GPT or Cloud, whatever the chat that has been happened and that you are going to give as a prompt, that is all counted as context. So model has I hope you know that model has a contextual limitation. Every model has this contextual limitation. That basically means how much information that a model can process in a particular sessions, and that depends on the model's capability, how advanced it is. So that depends, like so advanced model, basically they have a large contextual limitations or contextual memories, to be specific. So so here here we are. So whenever you give some prompt, model what counted as a context, your questions, your conversation history on that session. Let me write that very clear. And documents you shared, obviously. And then we have all right, so the tools. So tools, we'll talk about what is tools, why MCPs, resources, and obviously prompts. But prompts are also provided by MCP servers. Basically they are the templates. uh, so let's move to understand what is tools, what are resources, and what is prompts or MCP. So here, so model, whenever you are using an MCP server, there are three ways that MCP extends the context. Please remember, please understand this point. MCP extends the context of your model by providing by three ways, basically. One is through the tools, the other is the resources, and third is the prompt. Okay, so what are the tools? So tools are basically the functions that model can perform. So for example, if you are connecting to any databases, a model and depending on your permissions, securities, model allows what are the functions that you can call on your authentications. So basically run SQL or trigger DAG or send any kind of alert, which is basically taking action in any external systems, obviously. And then we have the resources. So a resource is basically a data that the model can read and load into its context. So how it will read, by reading the table schema, any kind of any your DAG logs or dbt documents. So that will enrich the context or enrich the ability of your model to provide you the accurate information or act. Yeah, so basically not referring to the let's say that we have an agent. So agent can perform multi-step multi-step actions or steps to get you the correct to complete a particular task. So let's say we have an agent. So agent can read your table schema, DAG logs, dbt docs, and enrich the context or it enrich its context with the live informations. And then we have third. So let's say we have this one as first, this is second, and let's say we have third. So we have some prompts. So prompts via MCP, it is not that prompt that you are giving to your agent. It's prompt that it's a reusable instruction templates. So for example, if you are using this analyze table, so that is there is some standardized prompt that will automatically come when this tool function will result will came out, and it will basically told the model how this information could be utilized. So so we can think of it's like a pre-written instruction, to be specific. Okay, for example, an MCP server data warehouse. So let's say we have a data warehouse. Okay, and it exposes a prompt template called analyze table. Okay, that takes a table name, returns a structured prompt asking the model to file the table's data quality. So the server defines the prompt and client uses it. All right, so hope you understand how the MCP extends the model context. And extending basically means the enriching the agent's ability to understand and perform the any actions by you know by uh, by its ability to do that. Okay, let's understand last thing. So we started with protocol. We understood what is protocol, we understood what is context, and now let's understand model. So hope you know that Cloud released this MCP servers or MCP protocols, but they haven't named it like Cloud Context Protocol, because they wanted they wanted all the models to use it, and they just don't want it to want that very specific to cloud models only. So Anthropic is the parent company who owns the cloud model, and because models could be your cloud, GPT, Gemini, Llama, or Grok, or anything. So so for example, if you have Airflow, BigQuery, dbt, so whenever you're switching between the models, your protocol becomes the stable layer, right? So because you have model. All right, let me just so let's say you have a dbt here, and you have an MCP server sitting, and now you are using cloud, but you decided to switch to OpenAI or Gemini or Llama. So you don't need to go and write every time to connect dbt, or not. You essentially you are not directly interacting with dbt directly. You are interacting with, you are connecting with MCPs only, MCP of dbt, and you're just switching very efficiently or very simply. So vendor dependency is lock in something that it resolves. Okay, so advantage, what are the advantages? I think I have already explained a lot on this, but let's, for the sake of this slide, let's just understand on this as well. So before MCP we has LangChains. So LangChains built its own tool format how to connect with external systems. Then we had a Llama Index. They also created an, or even every other company, they tried to build another form. So tools build one framework, unusable in another. So for example, if Llama Index has built, so LangChain could not use it, or so you have to write in a very different code. Integration, investment, and other efforts are also one of the key factors. With MCP, Snowflake builds one MCP server. All models can connect. Every MCP compatible app can use it. Atlassian, dbt, Airflow, one standard. Almost all companies are writing exposing their MCP servers, and so that different AI models can use them, like Databricks, Snowflake. There are, I think, Prophecy, MDM. I just heard that they have also exposed their MCP servers. Your internal tools write once, and any models can use it. Even if you have your own databases, you can also write your own custom MCP servers script, and make it in running in some app services. Okay, let's talk about the advantage too. So MCP servers exposes the tools. Tools are basically the functions or actions that a model can perform over your systems. So let's say all the tools and resources, so that model know how to query, how to interpret result, what to do next, which tools are available to use. So here uh, now we have a clean separation of concerns. Model does not need to uh, worry about how this is going to use. And all right, let's move to the next one. So here is the most important thing that model solves, and it is the clear security boundary. And now the MCP server is the trust boundary, and you control this basically. So basically, if it says only select is allowed, drop table is blocked, so Claude cannot drop any table in your data systems. So everything goes through these MCP servers, all the requests and alls, and model does not have direct connection to this to these direct systems. So that way you are controlling everything through the MCP servers. Even the authentication, so for example, if a user does not have the permission to run even a select query, then MCP server will fail or like that. But that is something is it has to be developed by the systems that is exposing that MCP server. For example, BigQuery has to have that layer. Obviously a lot of big companies are doing that, so that they are also authenticating who is who is the user querying behind the model, so that they can authenticate that as well. So that is the biggest use cases, or so the biggest security problem that MCP also resolves. And let's move what things we have learned today. We have learned what is model, we have learned what is context and protocols, any model, what is context, and how MCP enriches your context by providing three things we understood. It was prompt, tools plus resources, right? And then we have protocol. So no one owns it. Any model, any tool that follows the rules can connect to the MCP servers. So that way in this first video we have learned what is MCP server. In the next video we'll learn how the MCP works, the mechanics and servers, client transport session, and tool discovery, and everything behind it. And in the third session we will have a live demo, and we'll create a one of our first MCP server on our own, and we'll connect different models to it. Okay, thanks for being here. Let's meet in our next session. Thank you.